Hi, this is Danny Tang. I'll be doing the probability and stochastic processes homework 3. This is problem 1. Problem 1 asks, they give us the equation for a Poisson process as P number of customer arrivals in 0 to t minutes equals k, and this equals e to the negative lambda t times lambda t to k to the kth power over k factorial. So for part 1, it asks us to find the value of lambda when the probability that at least one customer arrives in 2 minutes equals 0.5. So when we solve this, we're given t equals 2, k is greater or equal to 1, because at least one customer is greater or equal to 1, or equal to 1, yeah. So you can write this probability as p, where k is greater or equal to 1, equals 1 minus p, where k is exactly 0, because you can eliminate no customer arrivals, and this accounts for more than one or more customer arrivals. So this is 2 minutes. 1 minus e to negative lambda times 2, and lambda t to the 0 power over 0 factorial equals 0.5. So we know that this goes to 1 because it's to the 0th power, and 0 factorial is also 1. So you would get e to negative 2 lambda times 1 over 1 equals 0.5, because when you move 1 to the other side, it's negative 0.5, and you divide by negative 1, so you get this equation. Oops. And so lambda comes out to be natural log of 0.5 over negative 2, which is 0.3466. So this is the value we'll be using for the rest of the questions. We assume that lambda is the same for this entire Poisson process. So part 2 asks, find a probability that in 10 minutes at least 2 customers will arrive. So we'll do the same thing we did in part 1. We write out t equals 10, k is greater or equal to 2. Lambda we found in part 1. So we write the Poisson expression as this: p, where k is greater or equal to 2, equals 1 minus k equals exactly 0, or and then minus k where k is exactly 1. And so you plug in all the values in, which is this expression over here. So then you evaluate this and you get it to be 0.8604. That's the answer. That's the probability that at least 2 customers will come in 10 minutes. And in part 3 it asks, find a probability that in 1 minute exactly 1 customer will arrive. So you write t equals 1, k equals 1, lambda is the same. And then what you would get is k equals 1. You just use the equation for the Poisson process, which is this. So you would get e to negative lambda times lambda, which is 0.2451. That is the probability that in 1 minute exactly 1 customer will arrive. In part 4, it asks, find a probability that in 3 minutes no customer arrives. So t equals 3, k equals 1, or k equals 0, and then lambda is the same. Again, you plug in values. K equals 0, and e to negative lambda times 3, etc. So this once again goes to 0, or it goes to 1. So you just get e to negative 3 lambda equals 0.3536.